Welcome students, happy to see you through this video and I am Ravi Shankar. So today we are going to study about the inferences about the electrical field due to electrical dipole. See, in our last class, in the previous two videos, we have calculated the electrical field at a point along the axial line and electrical field at a point along the equatorial line. I think you should have remembering that. What is the formula for electrical field at a point along the axial line? 1 divided by 4 pi epsilon 0 2p divided by r cube acting along the direction of dipole moment. Acting along the direction of dipole moment. Then electrical field at a point along the equatorial line is given by the formula 1 divided by 4 pi epsilon 0 p divided by r cube acting in a direction opposite to the dipole moment. I think you might be remembering these two equations. With the help of this, we are going to study or discuss about the results. That is what given in your book as inferences. What is the first inference that you can able to get? You take a ratio, you divide the electrical field at a point along the axial line with the electrical field at a point along the equatorial line. When you are taking the ratio between these two equations, shall I write again? 1 divided by 4 pi epsilon 0 2p divided by r cube whole divided by 1 divided by 4 pi epsilon 0 p divided by r cube, cancelling this 1 by 4 pi epsilon 0 1 by 4 pi epsilon 0 r cube and this p, so you will be getting the answer as 2 by 1, or very well we can say that the ratio is 2:1. See, when you are considering this as 2:1, you can write like this also. Therefore, electrical field at a point along the axial line is equal to cross multiply. You can write it out as 2 times as that of the electrical field at a point along the equatorial line, or reverse the case, you can write electrical field at a point along the equatorial line is equal to 1 by 2, or you can say half of, that is electrical field at a point along the axial line divided by 2. This we are considering it as the first inference. What is the second inference? Second inference we are going to state about the direction. What about the second inference? When you are considering the electrical field at a point along the axial line, the direction is same as that of the direction of dipole moment. This is for electrical field at a point along the axial line. Electrical field at a point along the equatorial line is, again we can write, we can say the direction is opposite to that of the direction of dipole moment. So this point we are considering it as the second concept or the second inference. What is the third inference? The third inference is let us write the equation again. What is that equation? See, electrical field at a point along the axial line is given by EA is equal to 1 by 4 pi epsilon 0 2p divided by r cube. Similarly, electrical field at a point along the equatorial line is 1 by 4 pi epsilon 0 p divided by r cube. When you are considering these two equations are valid only if the distance r where you are considering the point is very greater than that of the semi-length of the dipole. Length of the dipole is 2a, semi-length of the dipole is a. Suppose if you are considering like this, suppose the distance 2a, it's a special case, distance 2a is approaching 0, What do you mean by that? Approaching 0. The distance between the 2 point charges in the dipole gradually decreases. That is what I am saying, that it approaching 0. And the charge Q, the dipole is made up of 2 charges, isn't it? The charge Q approaches infinity. Then what will happen? So the charge Q approaches infinity means it is going on increasing, and the distance between the 2 charges go on decreases. What will happen? So what will happen means, let us consider this in the next line. See, when I am taking this, if you are considering the distance is taken to be approaching 0 and the charge is going on increasing, then we can say the dipole moment P is equal to 2A into Q, or I can write it out as 2QA is equal to finite, or is considered to be a finite value. Then if it is finite value, if dipole moment is finite, if dipole moment is finite, then the dipole is considered to be, the dipole is considered, or dipole is called to be point dipole, Do you know what do you mean by this point dipole? See, if you are considering the dipole having the distance 2a approaching 0 and the charge approaching infinity, charge go on increases and the distance between the 2 charges go on decreases, then the value of P will be finite. That is, the dipole moment, if it is finite, then the dipole is called to be point dipole. See, why we are saying this? For point dipoles, for point dipoles, the above equations hold good. Or we can say the above equations are exact and true. For any distance, or we can say for any distance r. That is what we are considering it as the third inference. These three are considered to be the inferences. See, what is the third point? The value of EA and EE are 1 by 4 pi epsilon 0 2p divided by r cube, and EE is 1 by 4 pi epsilon 0 p by r cube. These two equations are valid only if this distance r is very greater than that of A. Then only we can neglect the value of A. In this, suppose the distance 2A, that is the distance between the 2 charges, go on decreases, that is approaching towards 0, and the value of the charge Q go on increases, that is it is reaching infinity. Then we can say the dipole moment value P is equal to 2QA is a finite. If the dipole moment value is finite, then we can say the dipole is called to be the point dipole. then for a point dipole, the above equations, that is for EA and EE, are considered to be hold good, or we can say they are exact and true for any distance R. These 3 points are called to be the inferences of the electrical field at a point due to an electrical dipole either along the axial line or along the equatorial line. Okay, thank you.